So my name's Phil Waterworth. I'm from Endress+Hauser. I've got a couple of topics to discuss with you this afternoon, which I hope you find interesting. The first one we're going to touch on is about device configuration. So what are we going to cover in this session? Perfect for after lunch. There's quite a lot of acronyms in this presentation. So we're going to talk about some device configuration tools. What's out there that can help you to set up your devices. We're going to look at a couple of similar but different technologies that are available. We're going to have a little look at one of the tools as an example. And then we're going to talk about another, I say emerging, but it's out there, it's being used, another technology that kind of pulls it all together. So 3 acronyms we're going to look at during this session. But let's start with this picture here. This is a lovely picture of how it used to be. Maybe it is still the case in where you work, I don't know. But this guy here on the left has lots and lots of different bits of software which he needs to be able to set up all the different devices he has on his plant. This could be motors, this could be instruments, this could be inverters, it could be lots of different bits of kit. And every single bit of kit needs some different proprietary software so he can actually set up and make his plant operational. Not ideal. Actually that picture there, embarrassingly, is just showing all the different software that the company I work for used to provide. So there's about 15 different bits of software there, depending on the product you purchased, different software to set up these bits of kit. Not ideal. So, thankfully, that is no longer the case. There's a couple of technologies available which are designed to be one-stop shops for configuring everything. We've got a technology called EDDL, Electronic Device Description Language, and we've got a technology called FDT, Field Device Tool. So if you get down to the nitty-gritty, there's differences between these two, but fundamentally they're offering the same thing. They're providing you with a platform where you can configure all of your equipment you have on your plant in one place, vendor independent, device type independent. And these tools can sit either within your process control system, as shown here. Does this work? Maybe not. Okay, on the left there. So it can actually reside within your control system package that you have, or it can reside as a separate asset management tool, completely separate to your control system. And that is the case for both EDDL and FDT based packages. You can see here some of the statements that they both manufacturers are required to write driver types for each of these types of software. But once they're all in there, you can communicate with pretty much anything from these tools. So let's now have a history lesson. A long time ago in 1993, the Heart Communication Foundation, as it was called then, was formed, and they standardized this technology EDDL of a way to be able to communicate down to devices on a heart network and be able to configure them remotely. A year later, the Foundation Fieldbus Group and PROFINET PROFIBUS organization adopted this EDDL. So now there's a tool, configuration type tool, which allows you to talk over multiple protocols. And then in 2003, another technology appeared, FDT. This was a group that was formed in 2003. And we can see there that as time went on, they both became global foundations and groups providing the technology to be able to configure your devices, whatever they are. So, only got a half-hour slot, so I can't delve into these two different tools. So I'm going to take one of them as an example, FDT. And really what I'm saying here, generally EDDL works in a very similar way. FDTs, it's first of all, it's important to know that this is not a technology created by one particular manufacturer. This is an open, independent organisation. It's a non-profit organisation that looks after this technology. And actually, there's a whole host of companies who have who partake in this group to ensure that the technology is available and works with everything. FDT Group is responsible for developing the technology, promoting it, and that sort of thing. It's actually an international standard, FDT, and actually it's a group that you can anybody can become part of if you want to partake in the development of such technology and provide feedback on how the technology is working. Here's a snapshot of some of the companies who are involved with FDT. You can see on there's manufacturers of instruments, of motors, there's control system manufacturers, there's system component manufacturers, there's also end users as well. You'll see somewhere buried in there, I did spot it last night, there's an oil company, there's Petronas for example there. So there's end users also feeding back on development of this sort of technology as well. Okay, so how does it work? So FDT, as we said, stands for Field Device Tool. This is your frame application. So this is the front end that the user's using to be able to communicate and visualize things. You then have DTMs, which stands for Device Type Manager. These are the drivers which go into these packages, which allow you to get the information out of the devices that you want to set up and investigate. Mentions again, it's an open standard technology. It's independent of system supplier or device manufacturer. It's independent of device type as well, so drivers are written for sensors, for actuators, for remote I/O units, drives, etc., etc. And it's communication protocol independent. So obviously, being at a PI event today, it works with PROFINET, it works with PROFIBUS, but it also you're able to communicate to devices on many other protocols as well. So pretty useful. Takes you away from having lots and lots of different manufacturer-specific proprietary software to set up your devices and have one location where you can configure everything, but also store the information and the backups and all that in that one central place as well. So how is it working? So let's have a look at the left-hand side of this screen here. So this is kind of how it works in the background. We mentioned DTMs are the drivers within the packages. And if we look on the right side here, this is a sort of an example of a Profibus network as it was, with some sort of FDT tool. Again, this could be part of a control system or a separate asset management system. This is connected on an Ethernet network of some type. We've got a Profibus DP and a PA segment down here with potentially some sort of access gateway, which is linking your Ethernet and your Profibus together. And and basically from this top end, we want to be able to communicate to the devices at the bottom, which we've got some on Profibus. We actually have some here through some Profibus remote I/O. Onto HART. So again, a nice mix of protocols, not uncommon in process plants in particular. And we basically build up a project within our FDT package, which comprises of communication DTMs. So communication DTMs allow us to talk through networking components. So for example, this gateway, we want to talk through it from our software to be able to get down to the devices we want to configure at the bottom. And then at the bottom, we have device DTMs. Again, these are written by the manufacturers themselves to comply with the published FDT standard, so it'll work in any FDT frame, and many manufacturers provide FDT or EDDL frames. So yeah, so you build up your project based on the drivers and the devices you want to talk to. So Profibus, you can see here examples of devices you might have to have communication DTMs for. Perhaps you want to talk directly through a field controller, PLC type device, perhaps some sort of Ethernet gateway. There's also, you know, sometimes engineers want to use these tools on a laptop and directly connect to networks. So rather than having a central station that you're using to talk to these, maybe you want to take a laptop into the field and just review or commission some devices. So there's pieces of hardware you can use to connect to your laptops directly, USB drives. This is clearly a very old slide because there's PCI cards and all sorts of things mentioned on there, which I've not seen for a long time. But yeah, so they're all examples of bits of equipment that would require a communication DTM installed in your FDT frame. And of course, the manufacturer of these specific bits of a kit supply that communication DTM for these devices. And then of course down the bottom you've got the bits of equipment on your plant you want to be able to communicate with, so you want to be able to configure. You know, there's examples here of some instruments and some valves and motor starters. So the manufacturers of each of these specific bits of kit, again, will write the device DTM for these bits of equipment, so you can configure and set up those from your central engineering station or your laptop. And of course PROFINET, similar again. We've got at the top there we have various different screens. We've got SCADA screens and engineering stations and asset management systems. And of course on the asset management system we might have a configuration tool, an FDT tool. That, because PROFINET is Ethernet, will communicate down through all the various switches on the Ethernet based network. And we can see here we've got various PROFINET IO and what else have we got here? We've got some sort of PROFINET proxy to Profibus PA there. So again, things like the proxy and the remote IO will have communication DTMs by the manufacturer. Put that into the FDT tool. And the devices at the bottom on the different protocols, Profibus, PROFINET, HART, etc., IO-Link, I guess, as well in some situations these days. We'll all have device-specific drivers, put them into the software, you can communicate with all of that equipment and extract the settings and set them up. So again, one tool, configuration of everything. No longer do we have 3 million bits of different proprietary software we need to store somewhere. Let's just have a look at some examples of DTMs with an FDT frame. Here's an example of a valve positioner. You can see the thing you'll notice here is obviously the manufacturers write the DTMs, so they make sure that the information and the things you need to be able to access are available. But of course they have free reign with where that information is going to be within this DTM. So there's different looks and feels of how this information is displayed, but you can see here, very easy to access the alarms and set those up, review the travel, tune up your positioner, all of that information is there, very easily available. This motor controller here, you've got all the parameters and the possible configuration settings you would need to set up on that controller, very easily accessible. Actually, this is an example of some networking components. So this looks to me like the PROFINET to PA proxy, for example, and you can see there's various settings in there to set it up, but also it's giving us some diagnostic information as well at the same time. And so actually an important point here, and I think I may have skipped over it on one of the other slides, is whilst these tools started as configuration tools, they are also tools to extract diagnostics and health statuses from these devices now as well. And that goes with all of the devices we see in these, is it's not just configuration, it's also health and diagnostic information that's readily available. And of course, this is another example. This is a pressure transmitter. You can see here there's some nice visuals to help you set it up. All the information you need to set this thing up, the zero position, the maximum span, the type of application it's in, all in here. Again, you're effectively viewing this from the same package. Live demo. Okay. At the back today, I don't know if a few of you have been over to see me. On our slot there, we have some equipment set up. We have some PROFIBUS devices and some PROFINET devices. And what we've been showing on one of the screens over there is actually just a sort of an FDT frame showing how easy it is to get configuration information and also health. So what I'm going to do is plug this laptop in down here, which is the one that's connected to the stuff at the back. And we'll just have a little look at it and see what we can see. Okay, here's an FDT frame. Of course, it's the one that we provide because that's all I've got on my laptop. But this is showing the technology. So you don't be too mindful of the name at the top. But you can see here we've semi-built up a project already. We have added 2 communication DTMs into this project. One to talk on the PROFINET network, and one to talk through the proxy that's there. So you can see here, this one here is the communication DTM to talk to the devices on the PROFINET network, and then this communication DTM here is to talk to the PROFINET to PROFIBUS PA proxy. So we've added those in manually, so we're telling the software what we want to talk through. Now, in theory, I should hopefully be able to ask it to scan that PROFINET network and have a look at what's on there, check to see if it's got any DTMs in its library to communicate with that device. It's found something, it's assigned a suitable DTM for that device, and now I can effectively go online to that device. And I've now got instant access to all of the information that I might want to take a look at from that device on the PROFINET network. So information we see straight away is live measurements, tag details, all the different measurements being made, health status. First thing you see here is health status. Is this device working correctly? Actually, no, it's not. It's got some sort of diagnostic reporting, and it's saying here simulation is active. Okay, how do we resolve that? Well, you turn off the simulation. So straight away, we've got some diagnostics there, but then of course we have all these different menus, and this is quite a complicated bit of kit, really. Lots and lots of different options for setting up your flow meter there. Of course, once you've set it up live, you can download the settings, store them locally. Let's now take a look at the PROFIBUS PA network. So again, I've added in the communication DTM already. Let me go online to the proxy that's at the back there. Let me ask it to do a scan of what's on the PROFIBUS network. So off it goes. It's going to go and take a look and see what you got on your PROFIBUS PA network. Has a bit of a think. Again, it'll have a look. Should come back with something because there is something attached. There we go. So it said it's found 2 devices. It's read out the information of what they are. If I hit next, and it'll ask it to add to the project, what the FDT frame then does is it checks that it's got a DTM in its library for that device. If it has, it'll add it into the network on the left, and again we can then go online to those and check the configuration. There we go. Check the configuration, check the diagnostics, change the settings if required. Let's go online to this. There we are. There's another device on the Profibus PA network. It's connected. It's now going to extract all the information out. So this is doing exactly what people have been mentioning previously, is you might have all of your control data still going on with your devices, controlling your plant, but this is bringing up all that additional data that's in your devices. So you can check diagnostics, and you can check status and change all the settings. Simple. Okay. Oh, lost the presentation. F8. Duplicate. There we go. No. Got some sort of PDF thing going on down here. That might be causing problems. There we go. Right then, looks like it's jumped a little bit, this slide. So let's get rid of PDF Sam. Go away. It's usually virus scanners I get when I'm doing things. Right, let's just go back a few slides. Okay. Right, well, let's go back to our history lesson. So, where have we got to on this history lesson? We've got to 2005. We've seen that there's two tools available, technology, EDDL, FDT. We've had a bit of a look at how that operates in the background from an FDT point of view. Again, mirror that with what's going on with the EDDL, you won't be far wrong. And then we get to 2007, and something new starts, FDI. So this project, FDI standardization, was launched in 2007, and in 2011, all the major technology groups get on board with this. FDT, Foundation Fieldbus, Heart Foundation, Profibus International, OPC, all on board with this. So what is FDI? Why are people invested in getting on board with this? And that doesn't work at all now. Okay. So this is why. So, okay, great. We've got down to the point where there is two tools, but actually, end users were asking for a single. They're asking for a single solution. You know, yes, okay, that's great that we only have to choose from two technologies now rather than many different things, but they are similar, and because they're so similar and there's a bit of an overlap, it is causing a competitive situation. Bit confusing, multiple messages going out, so which one do I choose? Sometimes it's determined by your process control system provider. Sometimes it's forced on you. Sometimes if you try and choose, it gets very complicated to decide which one to go for, so confusing. And from a supplier point of view, to be able to make sure your devices can be configured through these multiple tools, you had to be a member of both organizations, and you had to invest in both technologies to be able to write these drivers and keep them up to date so that your devices can be configured through these two tools. So wouldn't it be better just to have one? So the objectives of this this FDI project is similar to what you'd expect, applicable to any device and communication technology, network independent, but also backward compatible. You know, what we don't want to be in the situation where we write a new tool, standard, and then just scrap what we've been using for many, many years, you know, for the last 10, 15 years. You know, that's just going to upset everybody. So it needs to be backwards compatible with existing drivers. And again, a bit like what we were showing with FDT there, it needs to be an open standard which becomes an international standard, so that it's not just run by one manufacturer pushing for their goals. And it needs to be independent of platform and operating systems. And this, of course, then would give you the benefits as an end user, single solution, compatible with your install base, existing and in the future, shared strategy and development by all suppliers, ensuring integration of all devices. So again, it doesn't matter what you've got on your site, who you buy it from, you'll be able to use this technology to be able to configure it. And just some clarity on the direction the technology is going in. So that's where FDI comes in, and FDI stands for Field Device Integration. And this is the opening paragraph on their website. It's been developed and supported by industry leaders. Advantages of FDT and those of EDDL are combined into a single solution. And it focuses on the different tasks required for devices through the whole life cycle. We're talking configuration, commissioning, diagnostics, calibration, all that sort of stuff. One tool, one technology. So let's just hit their promo video and take a look at that. Hopefully. The computer says no. Okay. Yeah, and it would usually load up with an obvious video as well. It just looks like a screenshot, that. Very strange. Okay. Oh, never mind. Never mind. Yeah, there was a nice video there, but it appears to have disappeared overnight. So, yeah, I mean, actually, if you go to this, the Fieldcom Group website is where all the information for FDI now sits. They have a lot of good videos on this technology. And actually, what the video I was about to show you, and actually, I could probably try and find it if we go onto the FDI website. Always good when you make things up as you go along, isn't it? We'll just have a quick look and see if I can find it quickly. If not, video library, here we go. Here we go, here it is. Right then.
People with ADHD save 10 hours studying with this Chrome extension. But no, by all means, go ahead.
That woke you up, didn't it? Okay, here we go. I've hit play.
What is FDI? FDI is an internationally standardized solution for process automation, device, and systems integration that dramatically simplifies software installation and maintenance, as well as communication between enterprise-level systems and technologies on the plant floor. Before FDI, individual devices often came with hundreds of files to address different systems, configurations, and interfaces. With FDI, a single device now uses one file to provide data and process values to all systems. An FDI system is made up of two parts, an FDI device package and a host system. The FDI device package is a standardized container of all files necessary to describe a field device to a system and a person, including the device description, user interface, and device documents such as wiring diagrams, manuals, certificates, etc. All of these elements are packaged together in a digitally signed FDI device package. An FDI host system in process control can be a DCS, PLC, an asset management application, or even a configuration tool. FDI host systems are made up of an FDI client and an FDI server. FDI hosts may also provide an OPC UA interface to field protocol communication servers, thus allowing disparate machines and systems to communicate. The communication server is the key element enabling FDI to be broadly adopted into the IIoT and Industry 4.0 initiatives. In particular, the server enables local or cloud-based OPC UA connections, which simplifies integration with existing IT infrastructures. FDI and OPC UA deliver access to plant data from across the globe, allowing corporate offices and subject matter experts to optimize assets and stay ahead of the competition, all while providing built-in data security. FDI and OPC UA enable the digital transformation of process plants to work more efficiently and effectively with fewer resources and tighter constraints.
Okay, so nice summary video actually. Interestingly enough, you'll start to see towards the end of that video some similarities to what's already been discussed today. So FDI is very much focused on communicating to the devices, getting the data out, configuration and diagnostics, but then we start to look at things like OPC UA links because this is what we discussed is the enabler really for IIoT and Industry 4. And so we now, FDI is working on having, yes, you can access the data from the devices, but then also have a method of getting it up to your relevant data sources, whether that be storing secure configuration backups in the cloud or extracting some additional data to populate your data lakes. Becoming quite powerful. So just to summarize that video, and let's just move on from there. Actually, no, let's go back. Thought there was another slide. So FDI tries to bring the benefits of EDDL and FDT together. Just one FDI package, which consists of an EDD, because they're much easier to write than FDT DTMs. Some sort of user interface plugin and lots of the documentation all in one package. Written by the manufacturer, very easy to get hold of. Put it into your platform, and then you're able to get the configuration, diagnostics, and of course with various different FDI tooling, get that data sent to other places if required as well. And we did mention before, we've got backwards compatibility as well. So here you can see an FDI host where the FDI package gets imported into the host, but no, apologies. Yeah, so the FDI package goes into the FDI host. It's in there, ready to use. You mentioned you got the FDI server and the client side of things. But also, we know it's backwards compatible, and so old EDDL files will also go into here. Okay, you probably don't have the same nice visibility and that sort of thing as an FDI package would now provide, but it's backward compatible. And if you've invested in FDT frames, you don't need to get rid of that and get an FDI package. FDT2 frames, so 2 is the second specification of FDT, will also incorporate FDI packages into them as well as EDDs. So everything works with everything else. So that's kind of where we're at from a device configuration point of view. FDI is not just a project these days. There are packages out there now, and there's FDI packages being written for devices as well. But FDT is still very much a current technology, and EDDL, and they're all working together to help you all. So that's device configuration. Here's a couple of links. FTT group, Fieldcom group, and Ask for FDI is actually quite an interesting website, really well formatted. Lots of nice, easy information about FDI, what it can help you as a consumer versus a supplier, and lots of nice videos in there as well. So these are the places to go for further information.